Download this code from codegive.com, link in the description below. Java pattern matching, a deep dive with examples. While Java didn't initially have dedicated pattern matching like Scala or Haskell, recent versions, specifically Java 16 and onwards, have introduced powerful pattern matching features that significantly enhance code readability, conciseness, and safety. This tutorial will provide a comprehensive exploration of Java's pattern matching capabilities, covering instanceof pattern matching, switch expression pattern matching, record patterns, preview feature, and sealed classes role in pattern matching. Why pattern matching matters. Traditionally, Java required a more verbose and error-prone approach to handling conditional logic based on object types. Consider this common scenario. This code suffers from several drawbacks. 1. Redundancy *, we check the type with instanceof and then immediately cast the object to that same type. 2. Potential for errors *, it's easy to make a mistake during the casting process, example accidentally casting to the wrong type, although the compiler helps catch some of these errors. 3. Verbosity *, the code is more verbose than it needs to be, making it less readable and maintainable. Pattern matching addresses these issues by combining type checking and variable assignment into a single, streamlined operation. 1. Instanceof pattern matching, Java 16. Java 16 introduced the instanceof pattern matching, which drastically improves the example above. The improved code looks like this. Key improvements *. Combine type checking and assignment *. The instanceof string str part checks if obj is an instance of string and assigns the object to a variable str of type string if the check is successful. No explicit cast *. The explicit cast, string, obj is no longer needed. The variable str is directly available within the if block, guaranteed to be a string. Conciseness and readability *. The code is more compact and easier to understand. Type safety *. The compiler knows that str within the if block is a string, preventing potential type errors. Scope considerations with instanceof pattern matching *. The scope of the pattern variable, str and number in the example, is restricted to the following. The if block itself. Any else if blocks following the if block where the pattern variable was defined. Any else block following the if block where the pattern variable was defined. Important note: the pattern variable is only in scope if the instanceof check is true. 2. Switch expression pattern matching, Java 17. Java 17 takes pattern matching further with the introduction of pattern matching in switch expressions. This allows you to switch on the type of an object, not just primitive types or strings. Syntax *. Key features of switch pattern matching *. Type-based matching *. The case labels can now specify patterns based on types, example case string s. Concise expressions *. The case labels use lambda-style arrow syntax, dash, to provide a concise expression to execute when the pattern matches. The expression's result is the value returned by the switch expression. Null handling *. Switch pattern matching requires explicit handling of null values. Failing to do so will result in a null pointer exception. Exhaustiveness * For switch expressions, the compiler requires exhaustiveness. This means that all possible input types must be covered by the case labels. If the input type is not sealed, you'll need a default case. Dominance * The order of case labels matters. More specific types should come before more general types to avoid dominance issues. For example, case object O should be the last case. Example illustrating exhaustiveness and dominance *. In this example, the shape interface is sealed, which means we know all possible implementations of shape. Therefore, the switch expression in describe shape is exhaustive because it covers both circle and rectangle. We don't need a default case. Important notes on switch pattern matching asterisk. Asterisk the pattern variable, s, I in the example, is only in scope for the corresponding case expression. Asterisk the compiler performs type checking to ensure that the expression in each case is valid for the corresponding type. Asterisk the switch expression must return a value of the same type for all case labels. 3. Guarded patterns in switch statements asterisk asterisk. Guarded patterns allow you to add more specific conditions to your case labels in switch expressions, beyond just the type check. You achieve this by using the when keyword. Explanation asterisk. Asterisk case string s when s.length, 5, this matches if obj is a string and the string's length is greater than 5. Only then is the corresponding expression executed. Asterisk case string s, this matches if obj is a string and the previous when condition was false. Asterisk the when clause effectively adds an additional Boolean condition to the pattern matching. 4. Record patterns, preview feature, evolving since Java 1920s. Record patterns are a powerful addition that allows you to deconstruct record objects within instanceof checks, switch statements, and, potentially in the future, other contexts. They help to access the components of a record directly. Example with instanceof asterisk. Explanation asterisk. Asterisk obj instanceof point, int x, int y, this attempts to match obj against the point record pattern. If obj is a point, it deconstructs the record, assigning the x component to a variable x of type int, and the y component to a variable y of type int. Asterisk inside the if block, you can directly use x and y. Example with switch asterisk. Benefits of record patterns asterisk. Asterisk deconstruction asterisk provides a concise way to extract the components of a record directly. Asterisk readability asterisk makes code more readable, as you don't need to call getter methods to access record components. Asterisk conciseness asterisk reduces boilerplate code. Important considerations for record patterns, preview feature. Asterisk preview status asterisk remember that record patterns are still a preview feature, so their behavior and syntax might change in future Java releases. Use them with caution in production code, and be prepared to adapt your code if necessary. Asterisk nested patterns asterisk record patterns can be nested, allowing you to deconstruct complex data structures. Asterisk placement asterisk as of Java 21, record patterns are available in instanceof, switch expressions, and enhanced for loops, a more recent addition. 5. Sealed classes and interfaces, enabling exhaustive pattern matching. Sealed classes and interfaces, introduced in Java 17, are crucial for taking full advantage of pattern matching, particularly in switch statements. They provide a way to restrict which classes can extend or implement a given class or interface. This enables the compiler to perform exhaustiveness checks more effectively. Example asterisk. Explanation asterisk. Asterisk sealed interface shape permits circle, rectangle, square. This declares shape as a sealed interface, meaning that only the classes listed after permits, circle, rectangle, square, can implement shape. Crucially, all permitted subclasses must be defined in the same module, or package, if the sealed class is not in a named module. This restriction allows the compiler to reason about the possible implementations of shape. Asterisk final class circle implements shape, final class rectangle implements shape, final class square implements shape. The permitted implementations must either be final, cannot be extended, sealed, further restricts extensions, or non-sealed, removes all restrictions on extensions, effectively breaking the sealed contract beyond the current compilation unit. Using final is common and generally recommended for simple cases. Asterisk because shape is sealed, the switch statement in getArea is exhaustive. The compiler knows that there are only 3 possible types for shape: circle, rectangle, and square, and the switch statement handles all of them. Therefore, no default case is needed. If you remove any of the cases or introduce a new, not permitted subclass, the compiler will throw an error because the switch is no longer exhaustive. Asterisk if we didn't have sealed classes and interfaces, we would need a default branch to satisfy exhaustiveness. Benefits of combining sealed classes and pattern matching asterisk. Asterisk increased type safety asterisk the compiler can verify that your code handles all possible subtypes, reducing the risk of unexpected behavior. Asterisk improved code readability asterisk the code becomes more concise and easier to understand because the possible types are explicitly declared. Asterisk reduced boilerplate asterisk less need for default cases in switch statements and complex if-else chains. Asterisk enhanced maintainability asterisk when the type hierarchy changes, example a new subtype is added, the compiler will remind you to update your pattern matching code. Best practices for Java pattern matching. 1. Handle null explicitly asterisk always include a null case in switch statements when dealing with nullable objects. 2. Prioritize specificity asterisk order your case labels in switch statements from the most specific types to the most general types to avoid dominance issues. 3. Strive for exhaustiveness asterisk leverage sealed classes and interfaces to ensure that your switch statements are exhaustive, eliminating the need for default cases. 4. Use guarded patterns sparingly asterisk guarded patterns, when clauses, can add complexity. Use them only when necessary to express specific conditions beyond just the type. 5. Stay up to date asterisk pattern matching is still evolving. Keep track of the latest features and best practices in each Java release. 6. Consider readability asterisk while pattern matching can reduce boilerplate, prioritize readability. Don't make your code overly complex just to use pattern matching. 7. Leverage records asterisk for simple data holding classes, use records. Then use record patterns to deconstruct the data effectively. 8. Embrace optional when appropriate asterisk use optional instead of null to help in pattern matching. Example optional with pattern matching asterisk. Conclusion. Java's pattern matching features have significantly improved the language's expressiveness and type safety. By using instanceof pattern matching, switch expression pattern matching, record patterns, and sealed classes, you can write cleaner, more concise, and more robust code. As the language continues to evolve, expect even more powerful and flexible pattern matching capabilities in future Java releases. Always keep yourself up to date to maximize the benefits of modern Java.